So now that we know that we can send energy wirelessly, the question is, how far can we go? Really, how far can we go? Could we put photovoltaics in space, solar panels in space, and collect that energy and send that wirelessly to Earth? This is not a new idea. The first time it was mentioned, it was in a short story, science fiction story by Isaac Asimov from 1941. And what I love about this story is that it's about a self-conscious robot. And the human is describing this idea to the self-conscious robot, after which the robot says, "Do you expect me to believe such a far-fetched, crazy notion? What do you take me for?" The first question, almost always is asked, is that, why do you want to put your solar panels in space? Why don't you put them up in the desert and be done with it, right? Few reasons. First is that in space, you get about 8 times more energy because you don't have day and night, you don't have clouds, you don't have seasons, and you don't have the atmospheric absorption. Also, now that you have this ability to send that energy where you want and when you want dynamically, you can imagine that you have dispatchable power. On top of that, it's an always available power. This can be used for a place, for example, let's say an island hit by a hurricane where there's no power, or a city in war zone where the power infrastructure is being constantly attacked. You can think about using this to send power to a remote village in sub-Saharan Africa where there is no infrastructure for power transmission, and that way democratize the access to energy, or send it somewhere above the Arctic Circle. So all of these things are great, but the question is, if it has been known for such a long time and it's such a great thing, why hasn't it been done so far? The main reason is that the way it has been envisioned before, they've been thinking about it as a big elephant. They've been thinking about putting big solar panels in space, collecting the power, generating a lot of energy, and then putting it into a massive parabolic dish antenna and sending it to a fixed location on Earth. Sending things to space is expensive. You pay dollars, and that's plural, per gram. The other problem is that even if you could afford it, assembly of something like this in space is still beyond the capabilities that we have today. So we came up with a very different approach, where we took our generators and turned them into flexible fabric-like structures. We are utilizing the amazing power of electronics, integrated electronics, and the flexible electronics to make these very lightweight, flexible fabric-like structures that you can roll and pack. And this allows you to have these satellites packed for launch and deployed in space, where each one of these units would be about several tens of meters on the side, and then you can pack a whole bunch of them and create a constellation of them that flies in space and forms your power station to send green energy to Earth. This will be flying in formation around the Earth. Obviously, this is not the size of the planet because we're talking about a kilometer across for the whole constellation, and the planet is a little bit larger than a kilometer. We've been developing, as a proof of concept, technology demonstrator, and this is called MAPLE, which demonstrates the power of flexible structures and electronic circuitry to generate and transmit power in space. We integrated that with 2 other technology demonstrators for deployable structures and photovoltaics that were developed by 3 teams led by myself and 2 of my colleagues, and we integrated into a satellite that was launched recently. And the purpose of this experiment has been to demonstrate the power transfer, wireless power transfer in space. Now, that brings me back to the promise of wireless energy transfer and what it could mean for us. I believe this technology is too compelling to go away. And I believe it's bound to appear in our lives in one form or another. And that is something to look forward to. Thank you.